Hello! In this video we'll be talking about section 2.2, Systems of Linear Equations with 3 Variables. In this problem we have the system of equations 6x minus 12y equals negative 5, 8y plus z equals 0, and 9x minus z equals 12. You'll notice something strange here is that all 3 of these equations only have 2 variables in them. Unfortunately, there is not any pair of them that have the same variables. For example, equation 1 has x and y, but there is no other equation that has both x and y in it. If we did, then we would just be able to combine those two together in order to get one of those variables by itself and move forward in that way. Instead, I am still going to need to approach this in the way of taking 2 of these equations to eliminate one variable, another 2 equations to eliminate the same variable if necessary, and then combine those together from there. Before I do so, though, I am going to rewrite all of these in the same consistent form of ax plus by plus cz equals 0. For example, for this first equation, 6x minus 12y, there is no z term, so I'm going to write that as plus 0z. You don't need to do this, but it will help to keep things organized. Same thing for the second equation. There is no x term, so I'll write that as 0x plus 8y plus 1z equals 0. And lastly, I have 9x, no y term, so plus 0y. And then minus z equals 12. At this point, as usual, you can use any 2 equations you want to try to eliminate a variable that is consistent between them. I'm electing to do equations 2 and 3 of these original set. I'm going to just add them together because I noticed that one of them has a plus z, one of them has a minus z. So if I add them together, that z term should cancel. So I'll do that on the side over here. I'm going to take equation 2. And I'm going to add equation 3 to that. So that will look like 0x plus 8y plus z equal to 0. I will add that with 9x plus 0y minus z equals 12. If I add those together, 0x plus 9x is just 9x. 8y plus 0y is 8y. The z terms will cancel, z minus z. And then this will overall equal 0 plus 12, which is 12. I will label this as equation 4. You'll notice now I have an equation of x and y, and our first equation also only had x and y, so I don't need to make another pair of equations to eliminate anything. I should now be able to just combine this with equation number 1. So if I look at those 2 equations, unfortunately one of them is 6x minus 12y equals negative 5. The other one is 9x plus 8y equals 12. That's unfortunate because there's not a single number I can multiply one of these equations by to make it so that I can eliminate one of those variables easily. For example, I can't multiply 8 by a whole number and create 12. I likewise can't multiply 6 by a whole number to create 9. But what I could do is multiply both of them by a constant to create something in common. So essentially what I'm going to be looking for is what we would call a least common multiple between those. I'm going to look at the x terms we have, 9x and 6x, and the least common multiple between 9 and 6 would be the lowest number that they both multiply into. That would be 18 here. 9 times 2 can be 18, and 6 times 3 will give me 18. So what I'm actually going to do is I'm going to take both of those equations, both equation 1 and 4, multiply each of them by a whole number, and then I'll put them together. So let's take equation 1. I'll put this on the side here. And I'm going to multiply that by, let's say, 3. If I do that, 3 multiplied by 6x minus 12y equals negative 5. I'll go ahead and drop the z term here since I will be combining that with equation 4. That will give me 18x. 3 times negative 12y is negative 36y. And 3 times negative 5 is negative 15. I am also then going to take equation 4, and I'm going to multiply that by, instead of 2, let's go ahead and do negative 2. That way I'll get a negative 18 for x, which will combine with a positive 18 from that first equation. So negative 2 multiplied by equation 4, 9x plus 8y equals 12. That will give me negative 18x. Negative 2 times 8y is negative 16y. And negative 2 times 12 is negative 24. Using these two equations, I am now going to add them together. So I'm essentially going to be taking my new equation 4. So I'm essentially going to be taking my new equation for 1, my new equation for 4, and adding those together. So I'll take 18x minus 36y equals negative 15. And I'll add that with negative 18x minus 16y equals negative 24. Negative 18x minus 18x will eliminate and just cancel. Negative 36y minus 16y overall would be negative 52y. And then negative 15 plus a negative 24, or minus 24, would be negative 39. Then I can get y by itself by dividing by negative 52. This will then give me y equals 39 over 52. Or if you simplify that, which you can use a calculator for if you need to, or both 39 and 52 have a common factor of 13, this will actually simplify to just y equals 3 over 4. Using that, we then should be able to plug that into some of our original equations and solve for the missing variables x and z. Let's say, for example, I will take, in this case, the second equation, and I'm going to plug y into that. So the second equation, 8y, I will plug in y to get 8 times 3/4 plus z equals 0. 8 times 3 divided by 4 would be 8 times 3 is 24, divided by 4 is 6. And then I could subtract 6 to get z equal to negative 6. I should also be able to plug in 3/4 into one of the other equations, or I could plug in z equals negative 6 if we so please. Really up to you. I'm going to take that third equation, 9x minus z equals 12, and plug in z equals negative 6. If I do so, I'll get 9x minus z, so minus negative 6, equals 12. That will give me 9x plus 6 equals 12. I could subtract 6 to get 9x equals 6. And lastly, x equals 6 over 9. Or if you simplify that, x equals 2 over 3. This would be now my set of solutions, which I can write my final solution now in terms of an ordered triple as x is 2/3, y is 3/4, and z is negative 6. I hope that gives you some more experience for working with equations involving 3 variables. Have a nice day.